We've now got a little scaffolding put together for our sorter class, and now we can start to think about the actual implementation of our sorting algorithm. Now, I know right now the kind of structure of our program might look a little bit strange. In other words, I know like passing in this array as an argument to some like sorter class, and then having that thing do the sort, maybe it feels a little bit weird right now. We are going to eventually discuss the overall structure of this program and figure out some better ways to structure it. So for right now, let's just focus on the actual implementation, and we'll talk about the overall structure in a moment. Okay, so inside of here, we're going to do our actual implementation of bubble sort. Now, sorting is, believe it or not the actual goal here of this application, so we're going to kind of speed through the implementation rather quickly. So first off, inside of sort, I'm going to get the length of our collection, because we're going to have to iterate through it inside of 2 nested for loops. So we're going to have to reference its length at least more than once. So I'm going to say const length is going to be this.collection.length. Now, if we want to, we can do a little bit of destructuring here to pull off the length property. So rather than what you see right here, I'm going to delete length on the end, and then put a set of curly braces around length like so. Remember, this is destructuring just the same as ES 2015 destructuring. So we are declaring a new variable called length, and its value and type is going to be coming from collection.length. Just to make sure that we can hover over this and we'll see that, yep, it is in fact a number. So Typescript has figured out all this destructuring stuff correctly. So now that we have the length, we're going to write out 2 nested for loops. And this is where the actual sorting algorithm is going to take place. So I'm going to say for let I equals 0, I less than length, I plus plus. And then inside there, I'm going to nest another for loop. I'll say for let j equals 0, j less than length minus I minus 1. So notice on here the less than statement, we've got length minus I minus 1. The minus I on here is what's going to account for the fact that after we do a full iteration through our array the first time, the rightmost element will be in the correct location. And so we don't have to try to resort that again in the future. That's why we have the minus I on here. And then at the very end, we'll do a j++ like so. Okay, so then inside of here, we're going to do the actual comparison logic and swapping logic. So remember, we are comparing 2 numbers or a pair of numbers each go around. So we're going to look at element j and the element right next to it, which would be j plus 1. We're going to see if the element as j is greater. If it is, we need to swap the 2 elements. So I'm going to say if this.collection at j is greater than this.collection at j plus 1. So that right there is what's going to compare the left-hand side of each pair to the right-hand side. If the left-hand side is greater, so notice the greater than sign, then we need to do a swap of these 2 elements. And so to swap them, we'll write out some very classic element swapping logic with JavaScript, which by necessity ends up being just a little bit ugly. So we'll say something like const temp is going to be this.collection at j, so get a reference to the element on the left-hand side. We'll then say this.collection at j is going to be collection at j plus 1. So that's going to take the right-hand side and throw it over to the left. And then we're going to take the left-hand side and throw it over to the right, which is done with this.collection at j plus 1 equals temp. Another name for the temp variable right here, which is very poorly named, would be to call it left hand like so. So that makes it a little bit more obvious that this is a reference to the element on the left-hand side of each pair. So we're saying get a reference to the one on the left-hand side, then take the element on the right-hand side and throw it over to the left, and then take the old left-hand value that we still have that reference to and throw it on the right-hand side. Okay, so that's pretty much it. This is our sorting algorithm, like implementation version 1 right here. So let's try saving this and flipping over to our terminal and seeing how we are doing. Now you'll notice that inside of my code base right now, I have no errors, no typos, nothing like that. So if you have any errors right now, chances are there is a typo somewhere inside of your code. So I'd encourage you to take a look and just figure out what is going wrong at present. All right, so I'm going to flip back over to my terminal. And I'll see that my array has been console logged out right here, and it is in the correct order, -5, 0, 3, 10. All right, so this looks good. We've got an initial implementation put together. So let's take a quick pause right here, and we're going to start to discuss how we're going to start to abstract out some of the logic inside of here and get this algorithm to work for all these different data structures that we want it to work with. So quick pause, and I'll see you in just a minute.